This week we are gonna solve two questions of vibration. The first one is free vibration, and we are gonna use Newton's law. In this question, a spring is stretched 200 millimeters by a 15 kilogram of block. So from here we can see that if we have a block, okay, and if this block is stretched by a spring with K, spring constant, and we know that this block has a mass which is mg, the weight. The force acting downward is mg, and then the spring wants to take to the equilibrium points, which is kx, is gonna be upward, right? So it's gonna be kx minus mg is gonna be kx minus mg is gonna be in equilibrium, right? And what is known here, x is known because it's stretched 200 millimeters. Mass is given 15 kilogram and gravitational force is constant, so we can find k, which is spring constant, from mg over x. Is this 15 kilogram multiplied by 9.81 over 200 millimeters, so it's gonna be 0.2 meters. So if you do this, we will have, let me calculate and then come back. Okay, it's gonna be 735.75. What is the unit? Is Newton over meter. So we find the spring constant, and what do we need to find? We are gonna find if the block is displaced 100 millimeters downward from its equilibrium position and given a downward velocity of 0.75 meters per second, determine the equation which describes the motion. So okay, we are going to describe the equation of motion. We know that equation of motion for free vibration, right? Free vibration. What it was, remember, it was x, the second derivative of x, plus natural frequency square x is gonna be equal to 0 if it is free, force if there is any force acting on it. So this is the ordinary differential equation we stated last week. So also we show the solution of x, if you have this kind of differential equation, how we are gonna solve is gonna be a sine natural frequency multiplied by time plus b cosine natural frequency multiplied by time. So let's take this one in the parentheses. So this is our general solution. As remember, the natural frequency is square root of k over m. We know the spring constant, we calculated 735.75, right? And we need to divide it 735.35 over 15 and take the square root in order to find the natural frequency. Let me calculate it. Okay, this is which is about 7. Okay, so we find the natural frequency. What else we can find as okay, we found this solution, general solution, but in order to solve this differential equation, we need to know the initial conditions. So the first initial condition, it says at time 0, when the motion starts, it stretched down 100 millimeters, so it's gonna be 0.1 meter, right? At the first position is 0.1 meter, and the velocity, which is the x dot, at the initial when the motion starts, is 0.75 meter per second is our initial conditions, because we have two unknowns, so we need to know two initial conditions. So how we are gonna solve? We are gonna say, okay, if I plug 0 instead of t, what I will get? X 0 is equal to a sine 0 plus b cosine 0 is equal to 0.1, right? So we know that sine 0 is 0, this is gone. Cosine 0 is 1, so I can see b is equal to 0.1. So I know right now for this kind of question, the equation of motion for b is 0.1. Okay, I found b constant, so right now I will use the first derivative of x in order to define a. So x dot, how we are gonna take the x dot? We need to take the first derivative of sine and cosine, so we can state it. So if I take the a is constant, if I take the first derivative of sine omega t, it's gonna be omega n outside, and cosine, sine is gonna be turned to cosine, natural frequency multiplied by time. Then plus b term omega n, which is natural frequency, minus sine omega n. Okay, so the first derivative of this solution is gonna be a omega n, like let's take the omega n in one parenthesis, a cosine omega n t minus b sine omega n t. If I take the x dot at 0 time, is gonna be natural frequency multiplied by a cosine 0 and minus b sine. Okay, we know that x dot is equal to x dot when the time is 0 is 0.75 meter per second. So let's just write 0.75 on the right hand side. And we know that sine 0 is gone, 0, and cosine 0 is 1. So we can state that A natural frequency is gonna be equal to 0.75. And we know that natural frequency is 7, so A is gonna be 0.75 over 7, which is A is gonna be like around 0.107. Okay, so our equation of motion x is gonna be, instead of A, I'm gonna write 0.107 sine natural frequency is 7, as we said, 7t, plus, instead of B, I will write 0.1 cosine 7. So our equation for displacement is this term, right? X is equal to 0.107 sine 70 and plus 0.1 cosine 70. So this equation displacement wherever like we can have, and we can state that this one x is equal to c sine, we can write it this one as like this, right? Sine 70 plus the phase angle. So we are gonna find phase angle here, which is here c is, as we stated, a square plus b square, right? So if you plug a square is 0.107, let's say 0.107 square plus 0.1 square root is gonna give us 0.147. 0.147. So x is equal to in this equation 0.147, and phi is tangent, arctangent, or inverse tangent of a over b, as again we stated for the phase angle. So arctangent, if you plug 0.107 over 0.1, this is, as we can see it, 1.07. We can say tangent, arctangent 1.07 is 47 degrees. So we can find our phase angle in 47. So we can write x in this form is 0.147 sine 7t plus, we can write 47 because it's in radian, so we can convert it to 47 into radian. It's about 0.82 radian. Okay, we know that if pi is equal to 180, 47 is what you can calculate it, and then you can find your 0.82 radian. So you are gonna write 0.82 here instead of 5, and we will find our equation in this term as well. Okay, so we solved our first equation for free vibration. In the second example, we have 20 pounds of block is attached to a spring, which is here, and the stiffness is 20 pounds over feet. A force is acting on the block with 6 cosine 2t pounds, where t is in seconds, and we need to write it down the equation of motion and determine the maximum speed and blah blah. We know that how we are gonna set up the equation of motion for the spring vibration spring with force. But let's use again the Newton second law and the Newton's law, which is F is equal to ma, right? Which is the equation of motion. We said the force acting, all the forces is make the block in motion, which is ma. And we know that the force is acting and the spring is pulling back. So F minus kx is gonna give us the motion, which is ma, which is F minus kx. Instead of a, we can write it mx double dot, right? So if we write it down in our standard form, mx double dot plus kx is gonna be 0. If it is free, it is F, because it is due to force, right? Force vibration. So we take the m, so we are gonna say x double dot plus the natural frequency square x is gonna be equal to F over m. Let's define this natural frequency, then F. So x double dot plus, which is it is k, which is k is given is 20 pounds, and over 20 pounds and sorry, 20 pound over feet the stiffness, and then 20 pound of block. If it is 20 pound of block is the weight, we need to convert it to the mass, because our motion is mass, is our unit is mass. So we are gonna say 20 over 32.2, which is the gravitational acceleration in British unit. This is for x, and we know that is gonna be 6 over m, which is 20 over 32.2 f. Sorry, it is cosine 2t. So if we simplified it, this x double dot plus 2020 is gone 32.2x is gonna be stay here, and this is equal to, we need to divide this term. When we divide it, it's gonna be 9.66 cosine 2t. Okay, this is our ordinary differential equation, non-homogeneous, ordinary differential equation for forced vibration, right? And we know the solution of this kind of equations is x is equal to a sine natural frequency t plus b cosine natural frequency multiplied by time, and plus there's a d0 over natural frequency square minus the initial frequency square multiplied by cosine 2t. So this is our solution for the this kind of motion. As what we need initial condition. So it says initially the block is at rest and the spring is unstretched. So we can say from here for our initial conditions x 0 at 0 and x dot, which is the velocity because it's at rest, so x dot, the velocity is 0 as well. And then when we have these two terms right now, let's jump to solve these AB terms. Alright, first let's write it down x0 by using this equation. So A when you take t as hold on, let me see. Alright, A when we plug 0 is gonna be sine 0 plus b cosine 0, and here is d0. Instead of d0 we can write it down d0 as we calculated above. Let me show. Here is 9.66, right? D0 is 9.66, so let's write it 9.66 over the natural frequency is this guy, so natural frequency square is 32.2 minus the initial one is here, the cos 2t is 2 square, so 2 is our term, omega 0 square, and cosine 2t is cosine 0, right? So this is equal to what? 0, because our initial condition is 0. A sine 0 is gone, 0. There is b plus 9.66 over 28.2. Let me see. 9.66 over 28.2 is gonna be 0.34. B is equal to then 0 minus b is equal to, because b plus this guy, minus 0.34, right, is 0.34, 0.34 cosine, there is no cosine, just 0.34, that's it, 0.34, b is 0. Let's calculate for a. How we are going to calculate a? We need to jump again. X dot, which is the first derivative of a, is gonna be a omega n cosine omega n t minus b omega n sine omega n t, and there is also here minus this guy is 0.34 is gonna be 0. From there is 2t, 2 is coming here, 0.68 sine 2t is equal to 0 again. So when we plug instead of time 0, this sign terms are going 0, and a omega n cosine omega n t. So this cannot be omega n, and cosine omega n t is not going to be 0. That means a is 0. Okay. So we can write it down. Our equation of motion x is gonna be what was the b? Minus 34 minus 0.34 minus 0.34 cosine omega n cosine, which is omega n is 32.2 t plus 0.34 plus 0.34 cosine omega t. 0.34 cosine 2t is gonna be our equation for x. All right. What can we find here? Hold on. The last one, to find the maximum velocity. In order to find the maximum velocity, we need to take the first derivative of these guys. So if I take the first derivative of cosine, it's gonna be this y is gonna be plus 0.34 multiplied by 32.2. Let's multiply it. 0.34 multiplied by 30.2 is 10.995. 10.95 sine 32.2 t, and is gonna be, this guy is gonna be minus, so it's gonna be 0.68 sine 2t. Okay, so what we need to do, we need to maximize it, this guy. If we want to maximize it, we are gonna say, okay, the short term is gonna be, so this guy is gonna be less time, this guy is gonna be close to 1, which is 10.91. When it's 1, what do we need to be? Time is gonna be 1 over 32.2, right? 32.2. So x max is gonna be equal to 10.95 because we want to maximize this guy, this positive one, and then we are gonna do multiply this guy minus 0.8 sine 2t is gonna be 16.1 1 over 16.1, and so it's gonna be let me calculate by the radian. Okay, so it's gonna be 10.95 minus 0.04 0.04. So the maximum velocity is 10.91 meter, is gonna be feet over second. So we find the maximum velocity. Okay.